So in this example, let's determine the maximum height and range. Now, when I say range here, I mean the horizontal distance traveled of a projectile fired at a height of h equals 3 feet above the ground with an initial velocity of 800 feet per second and an initial firing angle of 45 degrees above the horizontal. Okay, just a word to you budding physicists. We're going to derive this from first principles. So you're going to pretend like you don't know any physics, okay? The point is being able to derive this stuff and understanding what it is, okay? Let's draw a picture. Here we're just in the plane, so this horizontal axis could be called the x-axis, vertical axis could be called the y-axis. Now, you've thrown a few objects in your life. You've made projectiles. What kind of paths do they follow? Parabolas, yeah. Now, be careful. We have to start it at 3 feet, right? So h is at a height of 3, or h is 3. That's the initial height. And we'll draw, well, I'll attempt to draw a path that looks parabolic. And so this is a path that the projectile will follow. And in order to answer this question, we'd like to come up with R of t that describes this path. So the range that I'm referring to is the horizontal distance from where the projectile was launched to where it lands. We're assuming flat ground unless you're told otherwise. The initial height we could call, I suppose, h. h is equal to 3. That's the height you fire the projectile at. What else do we know? We know the velocity of the projectile coming out of the gun or whatever's firing it, right? So we could call that v, usually that's called v subscript 0, v naught. Now, we're assuming that R of t describes the path of the projectile. Okay, so that means that v naught would really be the initial speed of the projectile. And so symbolically, we could represent it as the magnitude. Okay, r prime is v of t, right? R prime of t is v of t. So it would be v of t where t is 0, the initial velocity. So it'd be the magnitude, it'd be the speed of that. It'd be the magnitude of v of 0. That's what v naught is standing for, but we usually just put v naught. And we know that that's 800 feet per second. So I'm not gonna put units in my intermediate work. I don't think they'll be that useful unless I'm doing unit analysis, which I don't need to do here. So, okay, so v naught, magnitude of v of 0, same thing, is equal to 800. Oh, I think from that, knowing the direction angle, so what do I mean by the direction angle? If you zoomed in right here, then the angle that this curve forms initially, you have to zoom in a lot, with the horizontal would be 45 degrees, or if you thought in terms of a tangent line or vector at the point of launch, same idea. The angle would be 45 degrees with the horizontal. So I think we could use that along with the 800 to figure out a formula for v of 0 as a vector. So what would that be? What would v of 0 be? Okay, we have a formula for this, right? So as a vector, you could say, okay, remember it's the magnitude times cosine of the angle for the first component, magnitude of v evaluated at 0, t equals 0, times sine of theta for the second component. Would you agree with that? So that would be 800 cosine, the angle is 45, I, plus 800 sine 45, j. So we're going to use exact numbers here. So both times cosine 45, sine 45, rad 2 over 2, right? You are expected to know the trig functions of those special angles. And so you multiply that times 800, you get the same number both times, right? 400 rad 2 for both components. So there, we weren't directly given v of 0, but we could find it pretty easily. And that's pretty much all we're given, right? But there's a little bit more information we know if we think about it. Can you still see that? I'm going to keep this screen here as long as I can without scrolling down. What's the only force acting on the projectile after it's launched? Gravity. Oh, yeah. So gravity is acceleration, right? So we could describe A of t, the acceleration vector. So A of t would be, okay, which form are we going to use, the metric or the English units? Well, the height is in 3 feet, right? So, okay, what's the acceleration due to gravity in English units? 32 feet per second squared. But it's pulling down, and the way our coordinate system is, we better make it negative 32j, okay? Because it's pulling downward. So negative 32j. A of t equals negative 32j would be our acceleration vector. Would you buy that? And we're looking for r of t, the path of the projectile. Okay, maybe I didn't make that clear. It says determine the maximum height and range. In order to do that, we need r of t, okay? We need r of t, in case I didn't make that clear. But I can get it by, if I want v of t, for instance, what do I do to a of t? Integrate. If I want then r of t, what do I do to v of t? Integrate. So we can get it. It's going to take a little bit of work. Bear with me. And then we're going to state the formula that we essentially develop here at the end. Okay, so let's do this. So let's see if you buy this statement then. V of t would be the integral of a of t, just as a generic statement, right? dt. That's the notation we use. Everybody okay with that? All right, so let's go ahead and integrate. So what would we get when we integrate? Well, okay, let me write it down. That's the integral of negative 32j. So I'm going to go down here. What do we get then when we integrate? Negative 32j dt, we should say. Just integrate the component negative 32 with respect to t. So negative 32t, j. And then we do need to add something. Plus a constant vector, right? So make sure you put that symbolism, that little half arrow over it. So I know you know it's a vector and not a number, not a single number. Oh, man, too bad. Too bad there's no way to find C. Oh, we know something about V of 0 when we plug in t equals 0. There is something we can do. So this is called, by the way, an initial condition, V of 0. It's called initial condition. You're going to hear that word a lot in differential equations. Many problems have initial conditions that allow you to solve for the constant. So, all right, just to keep everything kind of on the same screen for as long as possible, I'm going to go over here. And I'm going to go ahead and take V of 0. Now, remember, we have that V of t is negative 32t j plus c. I'm going to use that to take V of 0. What's going to happen to that j term when you plug in t equals 0? What's going to happen to this guy? 0, so I'm just left with c. But wait a minute, I know from up here, and I'll kind of point at things here, I know from up here then that c should be v of 0, which we obtained earlier. So that's going to be 400 rad 2 I plus 400 rad 2j. Does everybody buy that? Now let's put it back together then. What is, looking at this guy then, and what we just got for C, what is V of t? So, and let's go ahead and combine, you add corresponding components. Let's combine the J components, because we have a J component in C, it's 400 radical 2, and we have a J component already in V of t, negative 32t. So let me write it in order. The I component's just going to be, I'm going to put that in front of the J component right there. So that's going to be 400 radical 2 I, and then plus we need parentheses because we're going to have a quantity in front of the J, right? What's that quantity going to be? Okay, so 400 rad 2 minus 32t, and then the whole thing times J. Does everybody agree with that? So we've got V of t. Good news, right? But, oh, wait, we need R of t. So what do we do? Integrate again, yay! Or boo, depending on your perspective. So R of t, we're recovering R of t. That's just for bookkeeping purposes, we'll write down what that is. That's the integral of V of t dt, but we just recovered V of t, so we can do this. So that's going to be working downward here. That's going to be the integral of 400 radical 2I plus 400 radical 2 minus 32t j, and then let's not forget to try and fit in the dt on the end. Okay. And then integrate. Help me integrate this. What do I get? 400 root 2. Make sure you cut off the root so it doesn't look like you're taking the square root of t as well as 2, right? So it doesn't look like t is underneath the radical, in other words. And then that's I, right? Plus, oh, did I forget a parenthesis over here? Right there. Okay. And then integrate the j term. What do you get? 400 root 2 t minus 16t squared j. Does everybody agree with that so far? Just keep scooting over a little bit. And then what do I need to put on the end? Plus a constant vector. Oh, well, shoot, we already used c. Let's go back and call that c, c1, so that I can call this c, c2, I suppose. Although if you just cheated and called it C, nobody's really going to notice. You could, sure, yeah. Nobody's going to care. When I say nobody, I'm not going to care, and that's who grades your work, right? Okay, so does everybody agree with that? We need to find C2. Do we have an initial condition for R of t? I'm going to need to go back to my picture here for a second. Now, R of t is, well, when t equals 0, you're right here, right? So what would R of 0 be? It would be 3j. So I didn't write that down up here, but you get it from the initial height, right? So R of 0 is 3j, and there's your initial condition for your path that your projectile follows. So, so if this guy is R of t right here, I can plug in R of 0. Now what happens, looking at the formula that I just got, when you plug in t, what are you left with? Just C2. And then, oh, you know that that's equal to 3j, don't you? All right, so let's write down R. R of t then. If we fill in the 3j, so what do we need to do? We need to add 3j to the j term in our formula. That's essentially what that is, right? So I'm going to combine that into one quantity in front of the j. So that's not going to affect the I component, is it? So I get 400 radical 2 ti. Nothing's changed there. Plus, well, you could put the plus 3 right in front, or 3 plus if you write it that way. So we combine corresponding components, right? So we add them together. 3 plus 400 radical 2 times t minus 16 t squared, and then times the j. And that should be it. So this is the major hurdle. If you didn't know a formula for it, you need to find r of t, the path that the projectile follows. Of course, we haven't even begun to answer the question yet, but this will help us do that.